All right, in order to make my next point, actually, I'm pulling up the diagram I made, and hopefully you recognize that down here, those are electrons hanging out in that actually we would call 1s orbital. There can only be 2 electrons for each box. The boxes represent orbitals. The concept of degenerate orbitals only kind of kick in when you get actually multiple orbitals at the same energy level. So does this, you can almost see, does it look like these 3 orbitals look like they're at the same energy? And that means, let's say, we make them, the name for that actually is degenerate. They are equal in energy, and that actually has consequences. When we start to actually find what call find homes for electrons, we can have an electron in here, electron in here, electron in here, all at the same energy. So that's pretty cool. So in other words, to kind of reemphasize that, I'm going to kind of pick on 3D. A D-type subshell, of course, then has 5. You're looking at 5 orbitals. Okay, and these 5 orbitals are degenerate, so electrons in there would have the same energy. So that's all to say then, I'll go back to your slides. Degenerate orbitals or boxes that are actually in the same subshell. Just like I showed you, they're in the same subshell. Now, can an S-type subshell have degenerate orbitals? No, because there's only one orbital in it. Okay, but the P, D, and F. So, and this slide seems a little redundant, but a subshell of orbitals will be a group of boxes or orbitals that are maybe occupying, electrons are being occupied in there, and those orbitals will be of the same type at the same energy level, and all of those orbitals will be in that subshell are degenerate.